ever wondered how our Earth, the Moon, and the entire solar system came into existence? Today, let's explore some of the most important scientific theories, from the birth of the universe and the Big Bang to the formation of stars, planets, and finally life on Earth. This topic is extremely important for exams as well as for school exams, so listen carefully till the end. Theories of Earth's origin. Nebula hypothesis, Kant and Laplace. One of the earliest ideas was given by Immanuel Kant and later revised by Laplace. They suggested that the sun and planets formed from a huge rotating cloud of gas and dust called a nebula. As gravity pulled this nebula inward, it shrank, spun faster, and flattened into a disk. The sun developed at the center while the leftover matter slowly clumped together to form the planets. Planet-Symbol hypothesis by Chamberlain and Moulton. According to this theory, a giant star once passed close to the sun. Its gravity pulled out a stream of hot gases from the sun, shaped like a long cigar. When the star moved away, this material remained orbiting the sun. Over time, the gases cooled into tiny solid bodies called planet symbols. These planet symbols kept colliding and merging, eventually building the planets. Binary star hypothesis. Some early scientists believed that the sun once had a companion star. The second star's pull might have drawn material from the sun, helping to create planets. However, no evidence was ever found of this companion and the theory was discarded. Revised nebula hypothesis, Otto Schmidt and Carl Weizsäcker. This modern version improved Kant and Laplace's idea. The sun was surrounded by a thick cloud of hydrogen, helium, and dust. Collisions among particles caused them to stick together. Slowly, a rotating disk formed around the sun. Small clumps combined into larger ones through accretion, forming planet symbols and then full-sized planets. This theory is still widely accepted because it matches what scientists observe in young star systems today. Modern theories. Big Bang Theory, Edwin Hubble, 1920s. Around 13.7 billion years ago, all matter in the universe was packed into an extremely hot, dense point. This point suddenly expanded in a massive explosion known as the Big Bang. In the first few minutes, the lightest elements like hydrogen and helium were formed. After about 3 lakh years, the universe cooled enough for atoms to form and space became transparent. Formation of stars and galaxies. Matter after the Big Bang was unevenly spread. Denser regions had stronger gravity, which pulled more material together. These giant gas clouds called nebulae became the seeds of galaxies. Within them, clumps of hydrogen collapsed under gravity. Their centers heated up until nuclear fusion started, and this is how stars were born. Our sun formed around 4.6 billion years ago. Formation of planets. Around new stars, a swirling disk of gas and dust develops. The center becomes a dense core, the star, while the rest forms into small solid lumps. These lumps, through repeated collisions, turn into planet symbols. Gradually, a few larger bodies emerged. These became the planets of our solar system. The solar system. Our solar system includes the sun, which is a star, 8 planets, about 63 moons, and countless asteroids, comets, dust, and gases. Inner versus outer planets. Inner planets, Mercury, Venus, Earth, and Mars, are small, rocky, rich in metals, high density, also called terrestrial planets. Outer planets, Jupiter, Saturn, Uranus, Neptune. They are huge in size, made of gases like hydrogen and helium, with thick atmospheres, known as Jovian planets or gas giants. Why the difference? Near the sun, it was too hot for gases to condense. Only metals and rock formed solid planets. Solid winds blew lighter gases away from the inner solar system. Smaller planets had weak gravity and couldn't hold gases. The origin of the moon. The most accepted explanation is the giant impact theory. About 4.44 billion years ago, a Mars-sized body collided with young Earth. The impact blasted a huge amount of material into space. This debris slowly came together, forming our moon. Early Earth and its layers. In its beginning, Earth was extremely hot, barren, and covered with a thin atmosphere of hydrogen and helium. As it cooled, differentiation occurred. By that I mean, heavy elements like iron sank to form the core, lighter elements floated upward, forming the crust. This created Earth's 4 layers: crust, mantle, outer core, and inner core. Atmosphere and oceans. Earth's first atmosphere was stripped away by solar winds. Later, volcanic eruptions released gases like water vapor, carbon dioxide, and nitrogen. This process is called degassing. As the planet cooled, water vapor condensed and fell as rain, forming oceans around 4 billion years ago. Origin of life. Life likely began in ocean about 3.8 billion years ago. Around 2.5 to 3 billion years ago, tiny organisms started photosynthesis, releasing oxygen. About 2 billion years ago, oxygen filled the atmosphere, paving the way for more advanced life forms. Fossil evidence shows early life resembled blue-green algae. Geological timescale. From simple bacteria to complex human beings, life evolved step by step. The geological timescale records these changes slowly when major life forms appeared: fishes, reptiles, dinosaurs, mammals, and finally humans. So from a hot ball of dust and gas to a vibrant planet full of life, Earth's journey is nothing short of fascinating. If you are preparing for exams, remember theories of origin, Big Bang, formation of stars, planets, Earth's layers, atmosphere, and life all are key areas to study. Don't forget to like, share, and subscribe for more geography lessons made simple.